The answer is clear. Are our theoretical models incorrect, or is the universe at fault? The James Webb Telescope has recently captured a number of enigmatic findings that defy accepted cosmology. But what groundbreaking insights can be gained from these impossibly complex structures? Even though we know that our earthly home is only a small mosaic piece in a vast overall picture that we have not yet fully deciphered, it seems that every new discovery must first overcome a few internal hurdles. For example, consider the worldview of our distant ancestors who were adamant that the Earth was the center of the universe around which all other celestial bodies revolved. Are our assumptions about the age and/or of the cosmos still tenable? Or do we now have to admit that we have been on the wrong astronomical track for decades? Despite Edwin Hubble's recognition that almost all galaxies were traveling away from us, Albert Einstein added the cosmological constant to his field equation because he was so adamant about maintaining his theory of a rigid, unchanging universe. Looking back, we can say that Einstein later acknowledged his error, which he called the greatest mistake of his life, and that the movements of the galaxies that Hubble had discovered were connected to the universe's relentless expansion, which, as far as we know from official records, did not start yesterday, but it is possible to calculate backwards to a point where the density of matter and energy becomes infinite, and all spatial distances become zero by looking backwards at the corresponding development. This process, which occurred around 13.8 billion years ago with the Big Bang, defies initial assumptions by not describing a huge explosion into existing space with the rapid expansion of space itself from an original singularity matter, and time also emerged from this tiny, hot starting point. The discovery of cosmic microwave background radiation is another remarkable example of the Big Bang theory's accuracy. This remnant from the early universe is nearly isotropic and permeates the entire universe, making it widely accepted thus far. However, what should be done with discoveries that are incompatible with the Big Bang theory and its underlying findings? According to cosmological agreement, the first galaxies were still astronomical dwarfs when the first stars emerged. 300 million years after the Great Bang, it is understandable that there was insufficient normal matter in those days to create full-fledged galactic giants. The James Webb Telescope discovered something last year that, from a theoretical standpoint, shouldn't even exist. But the universe doesn't appear to be too interested in our theories. It did not take long for the Impossible Galaxies astrophysicist Evo Law and his colleagues at Swinburne University of Technology in Melbourne to discover something extraordinary. He quoted the initial reaction to the groundbreaking discovery after analyzing some images from the near-infrared camera NIRCam from the James Webb Telescope's early release program. The images showed a section of the sky near the Big Dipper, which is commonly known as part of the dawn of the universe. When I run the analysis software, it outputs two numbers, mass 100 billion stars and distance 13. I nearly spat my coffee out. I was aware that we had recently discovered the impossibly early and impossibly massive galaxies. The following demonstrates why the expert used the word impossible so frequently to explain the galaxy's existence. Either the density of matter in the young universe had to have been 2 to 5 times higher than what our models indicate, or the galaxies had to have formed in a way that we do not fully understand. In any case, scientists are faced with a significant conundrum. Both situations necessitate a significant shift in our comprehension of the universe, and scientists have not yet offered a convincing justification for this unexpected discovery. One thing is for sure: 500 to 700 million years following the Great Explosion. It is not unexpected that the research group calls the objects universe breakers because there were already 6 galaxies with 10 billion, and in one case even 100 billion, solar masses of stars, which made them identical to our Milky Way today. Cosmology has assumed that galaxies start as tiny clouds of stars and dust and gradually grow larger. But is it not possible that this is not the only way that stellar associations are formed? the discovery challenges what was previously thought to be scientifically certain, that the mass of stars in this phase of the universe is up to 100 times greater than what the old models suggest. This finding makes the specialists even more perplexed. However, this riddle still needs to be solved in the future, and the James Webb Telescope's upcoming discovery highlights how crucial this will be. In the same sentence, experts at the JWST Scuola Normale discovered that the 10 billion do gadget had discovered a new record holder and added another riddle to the star charts. Better, in Pisa, Jade's GS Z140 is the oldest known galaxy ever. The analysis of the collected data has shown that this gravitationally bound collection of stars and company was formed 290 million years after the birth of the universe. But that's not all. The bottom line is that it probably took around 100 million years to grow to its observed size. And speaking of size in this case, the researchers were not confronted with the faint baby galaxy that our current models predict, but with a structure that already contained several hundred million solar masses of stars. And once again, the question arises as to how this could have happened at all. In the early phase of the universe, how could such a bright and massive galaxy have folded in less than 300 million years? And why did a further analysis show that the spectrum contains oxygen, as well as emission lines of hydrogen, after all this fact indicates that several very massive generations of stars had already completed their life cycle before the experts examined this galaxy? Well, questions upon questions. But are there any answers in view of the discoveries presented so far? One might think that each new Webb discovery only plunges astronomers deeper into their scientific crisis of meaning. But that's not the case. Fortunately, there are more revealing answers. The origin of light in the early universe was explained by the so-called Dark Ages, when there were no galaxies, stars, or sources of light. Around 100 million years later, a dense fog of hydrogen gas filled the transparent neutral space, causing the hydrogen to become ionized and translucent once more. This process was literally plausible, and it was caused by the first very energetic stars that knocked electrons out of the hydrogen atoms. However, this is where things get complicated. For decades, some theories were based on the influence of black holes, but now Webb has lifted the cosmic veil and provided a detailed look behind the scenes of light. An international research team has found that small dwarf galaxies most likely produced enormous amounts of high-energy radiation. The researchers use Webb's near-speak and near-cam to track down this astronomical trail as part of the Uncover program. But sometimes a cunning trick is needed to make the light of very distant galaxies visible. This trick is known as the gravitational lens effect and refers to the deflection of light by large masses. The following principle essentially applies when light from a distant source is affected by an object that appears to be in front of it. The gravitational lens. The light beams are more deflected in the direction of the bulk the closer they are to it. In the case of the discovery mentioned above, this means that 8 faint galaxies were made visible through the lens of the galaxy cluster Abell 27 and 44, which normally elude our earthly gaze. The bottom line is that the structures are around 100 times less luminous than the Milky Way, and yet spectroscopic analysis showed that they emit 4 times more radiation than previously assumed. Consequently, astronomers were relieved to announce that they had finally tracked down the ominous photon source that once made the cosmos shine. But before we get it wrong, of course it wasn't these 8 small galaxies that ionized the universe, some 500 to 900 million years after the Big Bang, and made it translucent. Again, they are simply representative proxies, the low mass. Cosmic powerhouses occurred frequently enough in the early universe to collectively change the state of the entire universe, and conveniently for us, you occur frequently enough in the universe to change the state of the subscription button with just one click. Join our community now and never miss an exciting video from us again.